Welcome back to part 3 in curvature. So we're just going to kind of put everything together that we've been talking about. So we're giving this path of a curve. We have this path right here. Remember, R of t is a path. And part A, it says find the length of the curve from t equals 1 to t equals pi. And of course, we know how to find arc length. This is our arc length. So we're going to need r prime of t right here, and that of course is going to be negative sine of t. And this one right here, this becomes, be careful, 1 over t squared, because remember this is t to the negative 1, t to the negative 1, its derivative is negative 1 over t squared, but because it's negative we get positive, and we're going to get cosine of t. So when I want to find the arc length from 1 to pi, to get that arc length, we would take the magnitude of our r prime of t, of course. So, of course, when we do this, we do see the sine squared plus cosine squared. That, of course, will be 1. Plus, then I square this, I get 1 over t to the 4th. Don't forget your differential, dt. Now, we cannot do this one by hand, I promise. You don't want to mess with it, well, you can, but it's not very pretty for us. So, that's what we have a calculator for. So, I'm going to go ahead and type this in. Menu for, take the integral at a point, and integral. I would type that in from 1 to pi times the square root, and this is of the square root, 1 plus, and I can write this as just t to the negative 4, and I can even use t caret negative 4 dt. Press enter, and I get my answer, 2.289. Right there. Very easy to do. The next question says, find the curvature at 2 and at pi over 2. I am going to leave this one for you. Have fun with that one. Okay? There for you. Or just don't even worry about that one. I think that one just turns out way too nasty for us. Okay? But you can go and try that one. Alright, for part 5, for question 5, find the curvature of the graph at x equals 1. Now notice this is a circle, so what would you expect the curvature to be? Of course, it should be a constant for us. And this is rectangular, so we're going to use our kappa. This is going to be, remember, it's the magnitude or the absolute value of the second derivative of y over 1 plus y prime squared to the 3/2. So a couple ways I can do this. There are a few ways I can do this. One, I could solve for y, or I can just use implicit differentiation, finally an application for it, right? So I'm going to use implicits, okay? You might remember this from last year. If not, that's okay, just pay attention. We take the derivative of x squared, we get 2x. Take the derivative of y, we get 2y, y prime, that's that dy dx, equals to 0. Why don't you put dy dx? We don't need to anymore. We're already there. That's for last year. Solving for y prime, we should get negative x over y. So I got my y prime already, but remember I need my second derivative. To get my second derivative, I have to use quotient rule. So that's going to be low. D high, remember taking the derivative with respect to x, minus high, which becomes plus x times the derivative of the bottom, which is y prime, all over the bottom squared, y squared. Now you might remember from last year, we don't like y prime right here, so we're going to, of course, replace this with negative x over y. So we get y double prime equals negative y plus x times negative x over y squared. And if I simplify that, we are going to get negative y squared, because I'm going to multiply top and bottom by y, my LCD, and that's going to become minus x squared over y cubed. So there's our second derivative. So we got our first derivative and we have our second derivative. And we're plugging it in at x equals 1. So obviously I'm going to need a y value here. So if x equals 1, y is going to equal, and I can do that right over here. If x is 1, I get y is equal to the square root of 15. Now we get plus or minus, but remember we're going to take the magnitude of it anyway, so we're cool. So to get kappa, we're going to take the magnitude of our second derivative, which is this negative y squared minus x squared over y cubed, over 1 plus y prime squared to the 3/2. So let's go ahead and just plug everything in. If I plug in my y, let's take a look here. This becomes negative y, which is negative y squared, which is 15 minus 1. So that's going to become 16 over y cubed, which is the square root of 15 cubed, divided by, plug in here, ready? 1 plus, now be careful, y prime, if I go over here, is just x over y. So that's going to be, what's that going to become? 1 over the square root of 15 squared to the 3/2. And I ran out of room here. So solving here, we would get k equals 16 over the square root of 15 cubed over, this becomes 1 over 15, right? This becomes 1 over 15, which is 16 over 15 to the 3/2. Now, I'm okay you leaving it like this, and that's fine, but let's see what happens here. If I were to simplify this, this is really saying, and let's go ahead to another sheet of paper here, we'll take a look here. This is saying 16 over the square root of 15 cubed over, now watch what I can do here. I can factor out a 16 over 15, and that's going to leave me with a 16 over 15 to the 1/2. Same thing up here. This is really saying 16 over 15 times 15 to the 1/2. So I can scratch out those right here, and what I'm left with right now is 1 over the square root of 15 over the square root of 16 over the square root of 15. And those square root of 15s will cancel, and we're just left with 1/4. So there's our curvature. All right, that was pretty nasty, I'll have to admit, but I hope you enjoyed the algebra here. By the way, and I'll see you guys later. You guys have a good day. All right, bye-bye.